Hello everyone, welcome to Mind is Fun Education. In this video we will start with a new topic, that is the derived distribution. What does it mean by derived distribution? Let's suppose if you have this random variable x and this random variable y, and this random variable y is a function of this random variable x, right? And let's assume that this random variable x is a continuous random variable, then it will have the distribution. Let's suppose this will have the PDF, that is the probability density function. Now, since this random variable y is a function of this random variable x, we are interested in finding what will be the PDF of this random variable y. In case of discrete random variable, it will have the PMF, this x will have the PMF, and we will be interested in finding the PMF of this random variable y, that is the function of this random variable x. We will start with a very simple case, right? And why do we need to do that? So quite often we construct a model by first defining some basic random variable. These random variables usually have simple distribution and often they are independent, but we may be interested in the distribution of some more complicated random variable that are defined in terms of our basic random variables. So that is why we need to study, and we will start with a very simple case. Let's suppose a random variable, linear function of another random variable. So first let's look at the discrete case. So let's suppose if you have this random variable x and we have the known PMF of this random variable x, and we are interested in PMF of this random variable y, that is the function of, or the linear function of this random variable x, that is 2x plus 3. So let me also write what we are studying. So the first simple case that we are looking at, a linear function of a discrete random variable. Let me first of all also draw the PMF of this random variable x. So this is what the PMF that we have of x. Random variable x can take the value -1 with the probability 2 divided by 6. It can take the value 1 with the probability 1 divided by 6, and it can take the value 2 with the probability 3 divided by 6. We are interested in finding the PMF of this random variable y, that is the linear function of this random variable x. The very first step that you will take is that you will first, whenever you have the linear function, what you are going to do, you are simply going to scale the PDF by whatever the amount it is given. So let's assume that this z is equals to 2x. So let's first find out that how the PDF of the scaled version would look like. So the PDF of this random variable z, here x can take the value -1 with the probability 2 divided by 6. Then this z, that is 2 times of x, that means -1 times of 2, that means z will take the value -2 with the same probability, right? So it will take the value -2 with the probability, that is 2 divided by 6. Similarly, x can take the value 1 with the probability 1 divided by 6, that corresponds to the z taking the value 2 with the same probability, that is 1 divided by 6. So it will take the value 2 with the probability 1 divided by 6. And similarly, x can take the value 2. If x can take the value 2, z will take the value 2 times 2, that is 4. X can take the value with the probability 3 divided by 6. Similarly, z will take the value 4 with the probability 3 divided by 6. Alright, now we have this y is equals to z plus 3. That means what you are going to do, you are going to shift the PDF to 3 unit right. So now z can take the value 2, so y will take the value -2 plus 3, that is 1. Z can take the value -2 with the probability 2 divided by 6. Similarly, y can take the value 1 with the same probability, that is 2 divided by 6. So the PDF of this random variable y, z can take the value -2, corresponding to that y will take the value 1 with the probability 2 divided by 6. Z can take the value 2, then y will take the value 5 with the probability 1 divided by 6. Z can take the value 4, corresponding to that y will take the value 4 plus 3, that is 7, with the probability 3 divided by 6. Right, so it is simple, right? In order to find the PMF of linear function, first we scale and then we shift. So in general, if you want to write the PMF of this random variable y in terms of the notations of this known PMF, that is the PMF of this random variable x, how you can do that. So this PMF of this random variable y is nothing but finding the probability that random variable y takes the value that is little y, and these are the values that random variable y can take. So basically what we are trying to do is we are trying to write the PMF notation in terms of this PMF of x. We want to write the PMF of this random variable y in terms of the PMF of this random variable x, and we can proceed further. That would be equivalent to saying that y is a linear function, that is y is equals to 2x plus 3, taking the value this little y, and from here we can write that probability x is equals to random variable x takes the value y minus 3 divided by 2. And if we have to write this in terms of the PMF notation, this is how we can write that the PMF of this random variable y x taking the value y minus 3 divided by 2. Right, so this is how we can write the PMF of this random variable y, that is the linear function of this random variable x. So the PMF of this random variable y is equals to the PMF of this random variable x taking this value, that is y minus 3 divided by 2. So whenever y is 1, at that time that corresponds to x taking the value -1. Right, you can check y, if you put the y is equals to -1, 3 divided by 2, that would be -2 divided by 2, 1. Whenever y is 5, that corresponds to x taking the value 1. Whenever y is equals to 7, that corresponds to x taking the value 2. And if we have to generalize this, that given a random variable y, that is the linear function of this random variable x, that is ax plus b, and if you want to find the PMF of this random variable y in terms of this random variable x, then this is how you can write in general. So here we will have y minus b divided by a. Whenever you have linear function of random variable, then if you are interested in finding the PMF of this random variable y in terms of this random variable x, this is how you can directly write using this formula. So what it tells you, the probability that random variable takes a value that is equals to the probability of random variable takes the corresponding value. So if you are interested in finding the probability that random variable y takes the value 1, that would be equals to saying that the probability that random variable x takes the value that is y, that is 1 minus b is 3 divided by a is 2. So that is equals to the probability x is equals to random variable x takes the value -1, right? So okay, now let's move forward and let's look at a linear function of a continuous random variable.